Alright guys, today we're going to cover section 7.4, properties of logarithms, and I plan on dividing this into two separate videos. So we'll have probably 2 examples on this one and 2 to 3 on the next one. So what I want to do before we jump into the properties of logarithms is remind you a little bit about some of the properties of exponents. Remember, when we had x to the third times x to the second, when it was a multiplication problem, we added our exponents. Well, the same thing is going to be true for logarithms. When it is a multiplication problem, I have the log base b of m times n. I can separate that into separate logarithms by doing the log base b of m plus the log base b of n. So once again, multiplication and addition go hand in hand, just like with our rules of exponents. Also, to tie this to rules of exponents, when we had a division problem and we had the same base, the rule was to keep your base, subtract your exponents. So, very similar to that is the quotient property for logarithms, and that's when you have log base b of m divided by n. I can separate that out into 2 separate logarithms and do that saying the log base b of m minus log base b of n. Now, both of these properties can be used in both directions, meaning if I have 2 separate logarithms with the same base that are added together, I can put them back together as a single logarithm by multiplying these 2 things together. If I have 2 separate logarithms that have the same base and it's a subtraction problem, you can put it back together by doing the first one over the second one. Okay, put it back together as a division problem. Now, the power property is a little bit different. If we have log base b of m to the n power, what this rule says is you can take that exponent and move it out in front. And that's where they get this statement. And the flip side of that is when you've got a number in front of a logarithm, you can move it up here as an exponent, depending on what kind of problem you're working and what they ask you to do. So now, let's take a look at problem 1. It says simplifying logarithms. What is each expression written as a single logarithm? So if you'll notice, both of these are log base 4. So when I put them together as a single logarithm, it's going to be log base 4. But now, because this is a subtraction problem, when I put these together, I'm going to have the first number over the second number. Then I need to simplify this. So that's the log base 4 of 16. Now, this is a special type problem. We haven't seen one quite like this yet. And this lets me bring in another rule of logarithms in this problem. If you will notice, you can rewrite 16 as 4 squared. Well, this problem is unique in the fact that the base for my logarithm and the base for this exponent are the same. So what happens when the base for your logarithm and the base for your exponent are the same is all of this goes away and your simplified answer is just that exponent. And we'll see more of these a little bit later on. For part B, to rewrite this as a single logarithm, the first thing I have to fix is the numbers that are in front of the logs. So I'm going to move my 6 up here as an exponent, and I'm going to move the 5 over here as an exponent. So at this point, I have log base 2 of x to the 6th plus log base 2 of y to the 5th. Both of these are log base 2. So when I put them back together as a single logarithm, it's going to be log base 2. And then I simply multiply, since it's an addition problem, I'm going to multiply x to the 6th times y to the 5th. And that's all we can do for this problem. All right, so here are 2 guided questions. I'm going to go ahead and start working them out. You may want to pause and try them on your own, and then check it. Once you hit the play button again, check it with mine. All right, so when I put these together, it's going to be log base 4, and then I have to multiply 5x times 3x. So I get log base 4 of 15x squared. I'll be back with you in 1 second. Somebody's at the door. Give me 1 second, and I'll be right there.